Online classes for applied quantum mechanics. We will start with the uncertainty principle, which says that the position and momentum cannot be measured with arbitrary precision simultaneously. Now, this X and P are called conjugate pairs of operators. There are other conjugate pairs of operator like time and energy and angular position and angular momentum. The product of these conjugate pairs is always greater than or equal to h over 4 pi. But to understand under Heisenberg uncertainty principle, let's come back to position and momentum. So this uncertainty uh, in our measurement of position or momentum is not because of some measurement or some instrument which we use, but it is there because of the quantum mechanical nature of the things we are dealing with. In quantum mechanics, particles are described by waves, as you can see on your left, bottom left or lower left. So this wave, it has a definite wavelength, wave number, frequency, angular frequency, but it does not have a definite position, because you can see it is going all the way from left to right. Actually, it extends over all space. So if we want to make something localized from waves, then we have to combine lots of waves of different frequencies and waves, wave numbers, as you can see on your right. So we get this red localized things by combining these waves on the left. So this red localized thing is called a wave packet, and this wave packet has a definite mean value for the position and some uncertainty in this position. So the combination of this wave, we also call it a superposition. It is actually only summing up the waves, adding them. So this wave packet, it can be our model for a particle. So this is like an envelope, and the momentum of this wave packet or this particle, it should be the sum of the momenta of all the waves which we are using. So the momenta will have some range, and it will have some mean value. Let's say the mean value is p naught, and the uncertainty or the range of the momenta is delta p. So the position has a mean value x naught, and uncertainty in this position is delta x. So Heisenberg uncertainty principle says that the product of this delta x and delta p will be always greater than or equal to h over 4 pi. So we cannot reduce the uncertainty arbitrarily to very small value. If we increase uncertainty in delta p, then uncertainty in delta x will decrease. Or if we increase uncertainty in delta x, then the uncertainty in delta p will decrease. So even when we are not doing any measurement, this uncertainty is there. So this some notation which we use is that velocity of a single wave, uh, velocity of a wave with single frequency, wave number or wavelength, is called phase velocity, and it is represented by or measured by omega over k. Omega is angular frequency and k is wave number. And uh, velocity of a combination or superposition of different waves or a wave packet is called group velocity, and it is measured by the uh, differential of omega with respect to the wave number. So here all the information which I am presenting to you is either taken from your syllabus book, which is Levi, or otherwise I will mention the source on the slides. And that's all for today.